Alright, today we're going to start integration by substitution. There are many integration techniques, but you actually learn those in Calc 2. This is the one technique that we learn in Calc 1, and that's integration by substitution. So what we're going to do is we're going to get started, and we're going to go ahead and talk about how you would do something along these lines. If you look at this as it is now, I'm going to explain to you why you can't do it using the old method that we've been doing. This is what it says. You cannot distribute an x squared through. Had this been to the first power, we'd have no problem integrating this. So one of the things they do to start to teach you integration by substitution is they talk about just identifying the u and the du. And that's all we're going to talk about here at first. So what we're going to be doing is we're going to be transferring an integral into an integral with respect to u so that we can integrate it. So let me go ahead and try to explain that to you. Typically, and this is just a little side note for you, whatever's inside of a set of parentheses is what you want to make your u statement. So I'm going to show you off to the side. If I go ahead and write down what u is equal to, and we're going to just let u be x cubed plus 1. What we can now do is, because we need this dx when we go to rewrite or integrate, we're going to have to take the derivative of this. So we're going to write du over dx is equal to 3x squared, which makes du actually equal to 3x squared dx. Now, I will eventually, here probably not even on this next problem, skip that step, and I'll just always put the dx on the other side. Now, it does not tell me to evaluate this integral, but I do think it's important that you guys go ahead and see why this works out the way it does. If I was to replace each of these things with u, I would have this part I said was u, so I'd say that is u, and it'd be to the 1/2 power. Now the other parts that I have left, I need to find a d or an x squared and a dx. Now I have exactly that right there. So what I want to do is I would solve for that x squared dx by moving this 3 to the other side, which would create this 1/3 du. So then all I would have to do to replace my x squared dx is write in a 1/3 and a du. Now notice where I put that constant. We're always going to put those constants out in front of the integral. Now it does not say to go ahead and finish this, so that's all I'm going to do. Later we will evaluate the integral. So this problems again, it says determine whether it is necessary to use substitution to evaluate the integral. We do not have to evaluate the integral. We'll actually do that on the very next problem. So let's go ahead and think about whether or not we need to use some substitution in this. This would say x times x plus 4 to the 1/2 power dx. Since there is no way to distribute that through, this would definitely need substitution. There's no way to simplify this. On this one, again, we could integrate the cosine of x squared, but we could not integrate what we have here because we have two x's being multiplied together and there's no way to simplify this. So this would also require substitution. Now we will do examples like each one of these so that you can see how substitution will be used. I'm going to see if I can fit this into this video. So this one actually says to evaluate the indefinite integral. And what I'm going to go ahead and do is first rewrite this. So I have 3 minus 4x squared to the 1/3 power times negative x, or negative 8x dx. Now I told you when you make your u statement, you're typically going to pick what's inside the parentheses. So I'm going to try 3 minus 4x squared. When you take the derivative of this, you hopefully get something that was left over here, which is exactly what we got. I called this u, so I'll write u to the 1/3. And then I got exactly what I needed. Look how those two things match up exactly. So I get this. So now I'll just raise this by 1 and put it over it. This is an indefinite integral, so I have to remember to put my plus c. And so I get 4/3 u to the 4/3 plus c. Now we're not supposed to leave our answers in terms of u because it was an x's to start with. So my final answer would be 3/4 3 minus 4x squared to the 4/3 power plus c.